already written the rate equation, and this I am writing using the book Ghatak and Tyagarajan. Ghatak and Tyagarajan. So here it is. Here is the equation for 3-level laser, and we may call it a Q switching equation. dN2V by dt is equal to minus Kn. N is the photon number. K small n capital N plus K small n small capital N1 minus T21 N2V plus RV. Here T21 is the rate of spontaneous transition from level 2 to level 1. That means from the excited lasing level to the ground level. So because these two terms are very small, in case of Q switching, we may neglect them here because we have to discuss the Q switching behavior, and we consider the contributions solely due to absorption by N1 atoms per unit volume and emission by N2 molecules per unit volume. Further, we see a Q switched pulse is of very short duration. So therefore, during the last lecture, we discussed an introduction to Q switching and mode locking, and we saw that both techniques are used to obtain pulses of short duration and high power also. The effect of pump and spontaneous emission is neglected here, as we see here. So therefore, our above equation reduces to d by dt of N2V is equals to minus Kn N2 minus N1. Now this N2 minus N1, we may see the difference of populations between the lasing level and the ground level, and therefore we here on the RHS we divide and multiply by V. So this quantity can be substituted as this quantity delta N dash. V is the volume of the amplifying medium, and we have on the LHS we write N2V as N2 dash. So this becomes d N2 dash by dt is equals to minus K N by V delta N dash. In a similar way, the rate of change of level 2, level 1, that means the ground level, we can write easily d N1 dash by dt is equals to K N by V delta N dash. So this one is our equation number 2a and this one is our equation number 2b. We subtract these two equations. So we have d over d2 of N2 dash minus N1 dash is equals to minus twice Kn by V delta N dash. Or we can write it in a suitable form. D n dash delta n dash is equals to minus twice k n by v delta n dash by using this information. N2 minus N1 V is equals to delta N dash. So here I have delta N dash and here also delta N dash. So here we recall the oscillations. If the photon number is fixed, we have uh, oscillations here, and we may have, and we recall from the simple differential equations that dx, it is of the type of dx by dt is equals to plus alpha x is equals to 0. The rate of change of photon number n in the cavity dn by dt is nearly equal to kn by v delta n dash minus n by tc. This we have already seen in our discussion earlier, where Tc is the cavity lifetime, and during threshold population inversion we neglect the spontaneous emission again. So during threshold population inversion the gain must be equal to the loss, and so that we have, therefore, delta n dash threshold is equals to V over K Tc. This reduces, under this condition, the equation reduces to delta n dash threshold. That means the difference of populations during threshold but is equal to the volume V, the constant K, and the lifetime of the photon, cavity lifetime. See here, V is the volume of the amplifying medium. So this depends on the volume of the amplifying medium. And if we assume V by K to be equal to n dash threshold into Tc, we substitute, and we also substitute T by Tc as tau, and substitute in the above equation, we get equation 3 is this thing, d by dt, as we have considered it earlier. We see d over dt of delta n dash is equals to minus twice kn by v delta n dash. For this k by v, I substitute delta n dash threshold into Tc, and thus here we have substituted it, and I divide both sides by Tc, and thus I obtain dn dash by dt by tc is equals to minus twice the photon number delta n dash by delta n dash threshold. And we have just seen that this is the normalized time t by tc, and we have given it name tau, Greek alphabet that we encounter in the lifetime, the characteristic time. And now this is one equation, dn dash by d tau is equals to minus 2n delta n dash by delta n dash threshold. It is in the standard form, and from equation 4 what we see is the photon lifetime dn by dt is equals to n. Again we have substituted for V by capital and by capital K, and here its value is delta n dash threshold into Tc. So what we obtain, delta n dash into Tc, and because I have obtained we have V by K, so this will come in the denominator. This value will be substituted in the denominator, and we get dn by dt equals to n 1 over delta n dash threshold into Tc delta n dash minus n by Tc, or dn by d tau is equals to n delta n dash by delta n dash threshold minus 1. This we obtained by dividing both sides by Tc. So it will be removed from here, and n we have taken the photon number we have taken out of the bracket on the RHS. Now using equation 7, and this one must be 8, give the variation of photon number n and population inversion delta n dash in the cavity as a function of photon number n. So this equation is 8 rather. dn by d tau equals to n delta n dash by delta n dash threshold minus 1. Now if we simplify by dividing equation 8, the latter one, by the previous one, what we obtain, dn by d tau equals to n delta n dash by delta n dash threshold minus 1 by d by d tau of delta n dash equals to minus 2n and delta n dash by delta n dash threshold. Further, on simplifying and dividing the numerator and denominator on RHS by this fraction, what I obtain, dn by d derivative of delta n with respect to delta n dash equals to minus half 1 minus delta n dash threshold by delta n dash, and reversing the pulling the sign, some negative sign inside, what I obtain? Half of delta n dash threshold by delta n dash minus 1. Now we have to integrate this equation. I consider it, say, y, and this must be x. Then what I obtain? Dy by dx is equal to half of some x naught, may be there because this is the fixed quantity, x naught by x minus 1 inside the bracket. So these are the substitutions, and I separate the variables. Dy is equals to half of this thing, and by simple integration, what we obtain, this must be n minus x. So y minus yi is equals to half of x naught ln x minus x. The limits of integration being from xi to x, and on simplifying, what we obtain, because ln x minus ln xi is going to be ln x by xi, and x minus xi minus of x minus xi must be xi minus x. So ultimate equation is this: y minus yi is equals to half of x naught natural log x by xi plus xi minus x. Further, we substitute these. You know that y is n, x is delta n dash, x naught is delta n dash threshold. So substituting, we obtain n minus n I is equal to half of delta n1 dash threshold ln of delta n dash by delta n dash I plus delta n dash I minus delta n dash. This is our equation number 10. Now you can define the peak power. Peak power is the number of photons, that means the energy, and the energy uh, during which that energy is obtained, the time, the duration, the timeline. So n number of photons, energy of a single photon divided by Tc. So when P is maximum, n must be maximum. We substitute from here and we neglect this thing, and just on substituting, what we obtain, half of delta n dash threshold natural log of delta n dash threshold by delta n dash I plus delta n dash I minus delta n dash threshold h nu by Tc. Ni is neglected because a small number of initial spontaneously emitted photons in the cavity. So what we see, that the peak power is inversely proportional to the cavity lifetime. So it is all for now. You please go through it in the book Ghatak, and we shall meet during the next lecture, and we shall discuss about what may be the energy and the duration of the pulse. Thank you very much.